So today we are going to discuss basic properties of electric charge. This is from electric charge and fields of inter second year portion. So here we have discussed that there are two charges. So the negative charge and positive charge. Okay. So if these two charges are equal, then we can add these two and the effect can be cancelled. So if the sizes of charged body are very small, if you take two charged bodies, the size of two charged bodies are very small. Okay, compared to the distance between them. Say here this is one charged body, here this is another charged body. The distance between them is this is the distance. Compared to this distance, this is the very small. Then these charged bodies are called point charges. So all the charge content of the body is assumed to be concentrated at one point in the space. In the case of point charges, we assume that all the charges will be concentrated at one point in the space. That is why these charges are called point charges. Okay, and here we'll be discussing some of the properties of electric charge. First one is additive charge. Okay, so additive charge is something like this. Say for example, we have two charges. So it is same as how we do addition, the same way we'll be doing addition here. Okay. So if you have two charges, say Q1 and Q2, the total charge of the system is obtained simply by adding Q1 and Q2. Okay. So it is same as adding the masses. Okay. So what is the difference between mass and charge here is mass will be always positive, where charges will be positive or negative. So we have told that there are two types of charges, no? Positive charge and negative charge. Okay. So the charge can have positive value as well as negative value. Similarly, if you take the n charges, say the n charges are Q1, Q2, Q3, so on, Qn. Then the total charge will be just add Q1 plus Q2 plus Q3 plus so on Qn. That will give you the total charge of the system. Okay. So the charge has magnitude but no direction, similar to the mass. And what is the one difference between mass and charge? Mass of a body is always positive, where the charge can be either positive or negative. The proper signs have to be used while adding the charge in the system. Okay. So if the charge is negative means you have to take negative sign only. The charge is positive means you have to take positive sign only. For example, the total charge of the system contains 5 charges. Say here, some of the charges are positive, some of the charges are negative. So positive charges are plus 1, plus 2, and minus 3, plus 4, minus 5. Okay. When we are adding, we have to consider their sign also. So that whatever value you get, that is the addition of all these charges, which is having some value. Say negative means it is negative charge, positive means it is positive charge. Okay, so this is one of the property of electric charge, that is additivity of charges. And here we will be considering the sign of the charge, because the charge may be positive charge or negative charge. When we are adding charges, we have to consider the sign of the charge. And similarly, we have charge of conservation. What is charge of conservation here? How the charges will be, how we will be getting charges? We will be getting charges simply by rubbing. Okay. So when bodies are charged by rubbing, that is, there is a transfer of electrons from one body to the another body. So because of transfer of electrons, we will be getting charges. So usually we don't get no new charge either created nor destroyed. We are just transferring the electrons from one body to another body by rubbing the two bodies. So new charges are not created or destroyed. Okay. So that is called charge of conservation. So when we rub two bodies, one body gains in charge, other body loses. Okay. So whichever body gains charges, we are denoting with positive. Whichever body loses the charge, we are denoting with negative. Within isolated system consisting of many charged bodies, due to interaction among the bodies, charges may be redistributed. Okay, because of this rubbing. Okay, isolated system means it is not rubbed. It is not in contact. When these two comes in contact, what happens? Charges get redistributed. Okay, so if you see here, some of the some one body will be getting positive charge, other body will be getting negative charge. No, so if you add the total charge means the which body is getting positive charge plus the body which is getting negative charge. Okay, if you add those two, the whatever charge you get, that is equal to the total charge of isolation system. Okay, that is why it is called conservative. Okay, so it is not possible to create or destroy net charge carried by any isolated system, although the charge carrying particles may be created or destroyed in process. How it will be created? It will be created by rubbing. When you keep it in isolation position, what happens after some time, the charges will be destroyed. Okay. So sometimes nature creates charged particles. For example, you take neutron turns into proton and electron. Proton and electrons that created have equal and opposite charges. Okay, so the total charge is zero before and after the creation, because when you add proton charge and electron charge, the total will be zero. Neutron will be converted into proton and electron. So this is the second property. The first property is additive. Second property is charge is conserved. Third property is quantization of charge. Okay, so if you take all free charges will be integral multiple of basic unit of charge denoted by E. Okay, so thus the charge Q on a body, what is charge Q on a body is equal to N into E. E is called basic unit of charge. E is called basic unit of charge. Q will be always denoted by integral multiple of E. Integral multiple is some constant into E. N can be positive or negative. N can be any integer. It can be positive or negative. Okay. In the previous case, when we have discussed about additive, see here in the previous example, we are adding here. What is that we are getting? N as negative, like that. So here also N can be N is an integer. It can be positive or negative. Okay. This basic unit of charge is the charge that electron or proton carries. Okay, so we have discussed that neutron is divided into electron and proton. Electron will have negative charge and proton will have positive charge. Okay, by convention, the charge on the electron is negative, no? Is taken to be negative. Therefore, the charge on the electron is written as minus E. Okay, whereas the charge on the proton is denoted as plus. Okay, so the electric charge is always integral multiple of E is termed as quantization of charge. How we are denoting it as Q is equal to what? We are denoting like this. Q is equal to N into E. Okay, so this is called how we are denoting charge. We are denoting charge as an integral multiple of E in E. So N is called integral multiple. N is called integral. Something we are multiplying with E, that is why we call it as integral multiple of E. And this is called quantization. How we call it as? We call it as quantization of charge. Okay. So what is that here? So if you take international system SI units, the unit of charge is called coulomb. How we denote it by C. Coulomb is denoted by C. What is the meaning of coulomb? 1 coulomb is nothing but 1 coulomb is the charge going through a wire in 1 second if the current is 1 ampere. Okay. What is the charge flowing through a wire in 1 second if the current is 1 ampere? That is called 1 coulomb. Okay. And we have discussed that Q is equal to N into E. No? What is E? E is called the basic unit of charge. The value of basic unit E is equal to, what is the unit value? This is important. You have to remember this value. So it is 1.602192 into 10 power minus 19 coulombs. This is the value for E. We should remember this. Okay. Thus, there are about 6 into 10 power 18 electrons in a charge of minus 1 coulomb. Okay. So what is that we have discussed? We have discussed that Q is equal to N into E. No? Q is equal to N into E. Yes or no? So what is that they are given? Q is equal to 1 coulomb minus 1 coulomb. Okay. Then E value we know. What is E value is 1.60, okay, 2192 into 10 power. So power we denote like this, minus 19. Okay. Now can you tell me what is E? Yeah, what is N? What is N will be Q by E. If you find out what is Q by E, you will get N is equal to what? It is 6 into 10 power 18. What is this indicates? This indicates that here you see there are about 6 into 10 power 18 electrons in a charge of 1 coulomb. Means the 1 coulomb is very large value. Okay, whenever that is why whenever we want to discuss about the charge, we will be discussing so we will be discussing that the charge we have to take very small value of charge. We should not take very large value because means 1 coulomb itself will have so many number of charge. So that is why we don't discuss 1 coulomb when we are doing problems and all. We'll be taking small value of charge only. So if the protons and electrons are basic, only basic charges in the universe, all the all the observable charges have to be integral multiple of E. Okay, what is charge? Q is equal to N into E. So whatever charge, if you take a proton or electron, whatever charge, the charge should be considered as integral multiple of E. That is N into E. Okay. For electron, it will be negative. For proton, it will be positive. So if the body contains N1 electrons, what is that electron will have? What is the electron will have is minus E. Proton will have what charge? Plus E. The total amount of charge on the body will be equal to how many protons? It is N2, no? N2 into E plus how many electrons? N1 into what is the charge for electron is minus E. For proton, it will be plus E. So it will be written as N2 minus N1 into E. Since N1 and N2 are integers, their difference will also be integer. Maybe it is positive or negative, anything. Okay. Thus, the charge on any body is always. So, are you getting integer multiple of E from integer into E? So, we are getting integer into E and can be increased. When it can be increased, if integer is positive, it can be increased. If integer is negative, it can be decreased in steps of E. Okay, so if we have more number of protons compared to electrons, it will be increased. So if the electrons are more compared to protons, then it will be decreased in steps of E since it is multiplying with E. Okay, so what is the step size? How it is increasing? It is increasing with respect to E. No? So the step size is E. Step size E is very small because at microscopic level we deal with the charges of few microcoulombs. Okay, we are not dealing with the charge of 1 coulomb. We will be dealing with the charge of few microcoulomb. That is why with which it will increase. That will be very small. Okay, at this scale, the fact that the charge of body can be increased or decreased in steps of E is not visible. So it will be very small. It will not be visible. The grainy nature. So it is very small. No? That is why it is called grainy nature. It is like very grainy shape, size. So grainy nature of charge is lost and it appears to be continuous. So it is increasing in steps, no? So when it increases in steps, what happens here? We have to get like this steps. Okay, we'll be getting like the steps because it is increasing in very small steps. These steps cannot be visible. So instead of having this discrete steps, how we will be visualizing this? We will be visualizing this as continuous. Okay, it is visualizing it as continuous. So at microscopic level, one deals with the charges that are anomalous compared to the magnitude of charge E. Since E is given by this, the charge of magnitude, say 1 microcoulomb. So if you take 1 microcoulomb, we have used that formula. No? What is the formula? The formula is given like this. N is equal to Q into E. No? Sorry. Q is equal to N into E. So use this formula. What is Q value? Q value is given as 1 microcoulomb and E value we know. If you find out N, we will be getting N as 10 power 13 times of electron charge. Okay. So at this scale, the fact that the charge can be increased and decreased only in the units of E. Just now we have discussed, no? It will be increased or decreased in only in units of E. E is very small. Is not very different. It is not very different from saying that charge can take continuous values. Just now we have discussed that steps are very small so that it will be visualizing it as continuous. Thus, at microscopic level, quantization of charge has no practical consequences and can be ignored. Okay, so instead of having that steps, no, if you have that step, that is called quantization. Okay, the quantization of charge has no practical consequences and can be ignored. Okay, so with this we have discussed the basic properties of charge. So what are those properties? Additive charge, charge is conserved, and quantization of charge. So we can add all the charges. Whereas what is charge conservation here? We can neither create nor destroy the charge. Okay, either charge can be transferred from one body to another body. That is called charge is conserved. Quantization means that step size is very small. Quantization can be ignored in the charge. Okay, so this we have discussed here. Okay, thank you.